Steeped in history since 1880, when Leroy Sunderland Starrett invented the world's first combination square, the L.S. Starrett Company continues to manufacture tools not only at its Athol, Massachusetts headquarters, but in 4 other facilities across the USA and around the world. Starrett today proudly carries on its skilled tradition of precision, quality, and innovation throughout America.
The company was founded by Leroy Sunderland Starrett, who was a farmer from China, Maine. Long winter nights, he was a tinkerer. And his first invention was this, which is the meat chopper. He invented the modern combination square.
This is the story of the L.S. Starrett Company receiving the E for Excellence Award during the Second World War. So you got to take yourself back to April 22nd of 1943. The Army-Navy E flag awarded for excellence in war production today flies proudly underneath the stars and stripes on top of the L.S. Starrett Company's main building. The 2,300 Starrett employees standing in the pouring rain throughout the 45-minute ceremony cheered as Brigadier General Burton Lewis presented the flag to Mr. David Finley, President, who accepted it on behalf of the men and women whose production efforts were recognized by the War Department.
And this is where it all started. 1880 was when the company started. This is headquarters, Athol, Mass. Over 555,000 square feet of manufacturing space. You gentlemen will get tired today when we go on a tour. And you're going to see these American flags throughout the whole factory. Like I said in the intro downstairs, American manufacturing is the heart of the L.S. Starrett Company. To the right of me is we're going to enter our tool room. They're manufacturing fixtures and gauging. They're going out there and fixing our capital equipment. Any and everything to support the manufacturing of our parts and or finished goods, our tool room supports. As well as a dedicated tool and die maker. Where we're going to enter now is our grinding departments. So right here, what Chris is doing right now is we're grinding these rectangular bodies. That'll actually turn into, I believe it's our 183 protractor. And you can see to the left of me is another Starrett Vision system that we're using up here in our grinding department. So you're going to see Starrett tools, not only our indicators and gauging, or you're going to see micrometers, or our Starrett 673 50 millionths accurate bench mic. So we use our tools to measure and inspect the parts we're making that will eventually make our tools, along with our metrology equipment that's coming from Laguna Hills, California. So just walking through some more surface grinding. So what we got here is actually, this is eventually is going to be an indicator gear for the gear track assembly to make the needle move as you're measuring in a drop indicator. So what we have here, this is our thread grinding department for our micrometer spindles. So you see here we have a spindle blank. This has been 52100 steel, so it's rugged steel. It's been screw machined out or profiled. It has been heat treated, so it's very hard, which guarantees stability and accuracy. We actually put this through a freezer at negative 90 degrees Fahrenheit. It's called a season process that will actually stabilize the molecular structure of the tool that's inside of the tool, right? Of the spindle, of the steel. Now from here we're going to actually grind these threads on. So we're going to single point grind as it traverses across, and it's at 40 pitch, which we know with a 40 pitch thread, every revolution of that micrometer will give you a 25 thousandths measuring. So it's very crucial to keep the accuracy of the spindle and the hardness so the tool is accurate and does not wear in time. And then we're actually going to put it right here between these two carbide centers. We would actually look in here to see what the pitch diameter is and to see if there's any taper in the thread, up to a half a tenth. Now we are entering our micrometer assembly area. And one thing you will notice once we enter the micrometer area is all blue benches, opposed from all the wooden benches we've seen throughout the factory tour that are just darkened and oil soaked. So now we're going with steel, more ergonomic, better for the assembler to sit at and to move around assembly benches. So when you see the blue, that's new. And another great question, why did I choose blue, right? Because psychology tells us this type of blue is supposed to activate your neurons to bring you into the most positive mood. So we want our employees to come in here positive and leave positive. And with that type of mindset, the end user is going to get a positive tool. Over here is another new cell we have. This is our inspection for our micrometers. So micrometers are assembled and built to the right of me, and they come across a 5-foot aisle, right ready to be inspected. And if there's any quality issues or concerns, the inspector will bring it right back to the assembler to go ahead and fix that and get it right back to inspection. As Starrett is entering into a lean culture, the more efficient way of manufacturing, you also see the gray banners. There's not only the American flag, lean manufacturing, but what we did is on the back side of the banners, we just put some more positive sayings. Yep, so we can see Ryan inspecting our Cadillac T230 XRL 0 to 1 inch, forged frame, chrome plated micrometer. Ryan is using our Weber gauge blocks that come out of Cleveland, Ohio to make sure that the lead accuracy of the linear measurement is within spec. That's a 10th reading tool. So now we're entering what the world doesn't know is the Starrett micrometer as our classic 436.1 micrometer. Well, the reason why I brought you into this area to talk about lean manufacturing and being more efficient is this cell can now assemble the 436 family from 1 inch all the way to 24 inch. Where about a year ago, a person would build the 1 inch mic over there, another gentleman would build the 2 through 6 inch series of micrometers in another area, then another gentleman would build the 7 to 24 inch in even a larger area than that. What we have done now is condensed it, cellular U-shaped flow, start to finish, bringing in that entire family 1 to 24 inch. And we can see Johnny Bascalupo, almost a 30-year veteran, our most skilled micrometer builder. And Johnny just does his thing and can build the mics with the best of them. Now we're in our large micrometer cell where Mr. Rocky builds our large mics. You can see right here, I'm guessing that might be 10-foot range. And over here in the corner, we have some of our tubular mics. That's all steel fabricated and welded together. So they're very lightweight. Very, very, very lightweight. You can see how light that is. I'm not the biggest guy, but it's very light. Yeah, so what we have here is an inspection cell for our scales. The well-known Starrett granite, pink granite that we are known for, comes out of True Stone Technologies in Minnesota. And basically I would turn on a light and just look for any light between the scale and the granite. And if there's light, then that tells me that this surface is not flat. So in the 144 years as the Starrett company grew and expanded its product line, needed more manufacturing floor space. So you're going to see a lot of additions as we go. And as mentioned, now we are actually entering our tunnel underground across the street to the heart of the factory, as I call it. So now we're going to be entering our tumbling department, or also known as mass finishing, where we have 3 processes inside that tumbling or mass finishing. One is called a cut down. 2 is called a blend, and the 3rd is called a brighten. American manufacturing right here in Athol, Massachusetts. And it sounds like it's lunchtime. And another thing that we're starting here too, following TPS, Toyota Production System, lean manufacturing. But we have our safety, quality, on-time delivery, and cost board. So it's a daily board that's updated where we can review the metrics. Long story short, visible management at its best. So here we got our hour by hour boards. This is for hourly tracking. You can see here we missed something. So the question is, why did we miss 1/3 of the capacity? Visible management gives us visibility to improve, continuous improvement, Kaizen, lean manufacturing. Right here on this old Cincinnati Miller, we have our thread pitch leaves, right? So we punch press them as a blank. Now we need to mill the teeth in it. So we go ahead and string up 50 of them. We'll clamp them in the fixture, and that cutter obviously designed to, I'm not sure what pitch this is going to be, but we'll go ahead and grind those teeth to get that thread pitch that's needed. So we have our feeler gauge, and that's the name of it is just that, feeler. So if you're looking for the width of a slot, you can go put that in there and kind of feel the tension. And as you pull that out, as soon as that tension is felt, then you know that distance or that width of that slot or hole that you're trying to measure. He'll come over here, check on our Starrett gauge here with our catalog 81 to check centrality of that hole, as well as put it in here for the overall length of that. We have a dedicated tool and die maker that will maintain all of our tool and die sets. Now we are going to walk into where it all starts, screw machine. I'm going to say probably 90% of our parts start at screw machine. So right here is a display table of the parts that start in our screw machine. We have a brass case here. That's actually where the dial is going to sit for our catalog 120 or our dial caliper. Right here is actually a micrometer stem for a 0 to 1 inch. Our T465 or our T468, 50 millionths accurate mic head right here, that's the stem. Here's your inside and outside tube for our 98 levels. Those that are familiar with our 98 levels, right? I can close it up. I would open that up and there would be the vial or the glass to see if my level. Some other things we have here. A micrometer shell. On the Namor, we are able to machine this start to finish with all the geometries, dimensions we need while maintaining a 50 RA max surface finish. So the story to that is a minute and a half, this comes off a machine and it's ready for chrome plate and laser mark. So just technology continuously improving. Right here's the case or the body to our 196. That will be our back plunger indicator. Made out of brass there, and you can see some of these tiny screws that actually do have threads on them. Where we are entering now, we call this building 22. This is where the saw line started for Starrett Athol. This is when Leroy Starrett back in the 1800s, with his innovative mind, as he was making some tools and coming up with a concept, he had to cut some of his material. So he started manufacturing or making his own saw blades. Over here is our incoming inspection for our castings and our forgings. Anybody guess what this is going to end up being? Square stock, I know. Good guess to the audience out there. So yeah, this is how it comes in, and we're going to go ahead and do a bunch of machining, slotting, drilling. So I saw this on social media about 2 weeks ago, that they didn't even know what this was, didn't even know that the scriber was in the tool. So yeah, so we provide a scriber with the tool, so as you're doing your layout work, you can take the scriber out and go ahead and mark your measurement. So for those that didn't know, there's a little insight.
And here is our impressive automated Mazak cell where we perform the machining operations of center heads and square stocks for the combination squares. We load up a number of tombstones so the Mazak machine and pallet technology can efficiently mill, slot, and drill parts. Machining automation at its best.
So we're going to enter our QC, quality control. So here, you can see right here, this is our catalog 20 toolmakers square. So they'll come in here and measure it up against the master. Right here you can see we have our different stack gauges, height gauges, our amplifier box here to get down to the millionths to read, where they're just going to go ahead and continue to calibrate tools, whether it's an internal tool or a tool that's going to end up in the end user's hand. Now we're going to enter our ATD division, or our Advanced Technological Division, where they're doing some electronic final assembly. What we're going to show you here is a brief assembly of our new W4900 touchscreen digital analog interface drop indicator.
This is the inside part of the indicator, which is where the accuracy of this tool comes from. It's a glass scale with a read head and there's an LED light that shines down through it, and it's picking up a combination of light and shadow to give us an accurate measurement.
It's wireless, so with a push of the button, you could send that measurement to your back pocket within 30 feet to your cell phone, or within 200 feet to your PC. So we're now on the back side of our indicator machining. So we have our hobbing cell right here. And just to give you an idea of how small the parts are that we not only manufacture, but what we go ahead and assemble to make our indicators work, it's pretty impressive. So just for comparison, here's a bunch of parts that are machined back here in comparison to the size of the diameter of that penny. But here you can see some spirals right down there. now we're just going to look at our first assemble. That is what Sue is doing. She just slid in that gib, which will create the tension for the perfect feel of the tool as you're sliding the caliper during your measuring.
Maintaining high standards for quality and precision in the accurate tools they make requires skilled craftsmanship, an unwavering hallmark of Starrett that's difficult to automate. Yet, the company's ingenuity has led to automation solutions at its venerable Athol plant.
Now we're in our laser marking micrometer department, where we go ahead and laser mark and put on the graduations, the numbers, and the Starrett name of all of our outside and inside micrometer shells. So you can see right here, we have a UR robot that's going to take that inside shell off the arbor. It's been laser marked. I'll go ahead and put it onto the pallet, pick up the next one, load it, and run through the cycle. So you're entering our punch cell, our punches, right? Starrett is known for our punches, all automated. And once again, the automated is to not replace people, but to redeploy them into a more value-added position, as well as fill the positions that we're struggling with hiring. So now we are entering our indicator machining. This is a bridge plate that's going to go to a drop indicator. And see that red ruby? We used to have an employee who would actually press all these jewels, these ruby jewels, and now we have an automation system that will go ahead and do it for us. So right now I have a green, that's our boundary sample. So this is a good tool that we can physically use to check torque and to check force and run of the indicator, where before it was all subjective. My feel versus your feel versus your feel. So now once we did this Kaizen event to protect the customer, which is the assemblers, and then the inspector, we've developed some fixturing on one of our force measurements that will actually calculate it all out and show you whether it's good or bad. That way we can take that subjectivity out of the inspection in the feel of the tool.
Any company that's succeeded as long as Starrett has continually improved. At Starrett, Kaizen is essential for both the company and its customers.
So here we are now is our warehouse or our crib of micrometers. If you look, you can see a bunch of spindles that are in stock on the shelf. But the reason why I brought you in here is you can see this whole empty space right here. So back in October, we brought in about 30 people from different portfolio companies, what we call a Kaizen boot camp, where it was an intense Monday through Friday, 12, 13-hour days of 4 teams with 4 different projects of doing all lean manufacturing improvements. Kaizen, right? Japanese for continuous improvement. So that's why you see a bunch of empty space right here, where we're actually taking 4 different assembly department warehouses and combining it into one. And this project should net a reduction of 2,200 square feet. And those of us in manufacturing, we know for every square foot, that's a cost to the bottom line of the company. All right. Now I'm going to introduce you to 2 new formed areas that we have. Lean manufacturing, Kaizen, continuous improvement, right? Visible management. So right now we're going to walk into our Obeya room. And for those that don't know, Obeya is just visual management of tracking of crucial, critical components to the business. So currently we have 6 projects in Obeya. We have boards that will talk about quality, our production and throughput, and if there's any PFS, problem follow-up sheet. So if there's actions, and then there's going to be a countermeasure to close that out. We use this for tracking. We meet about 2 to 3 times a week with the supervisors, the stakeholders, their champions, to make sure the countermeasures are being implemented. Now we are going to enter into the Starrett Solutions Center, where we meet every day for 2 hours a day with our dedicated teams of engineers, where we're focusing on quality issues, throughput, is there a cost reduction to increase our gross margin, or even pass on that cost reduction to our end user, to where the volume might increase. Any and everything to make a healthy bottom line. We meet here dedicated 2 hours a day. Our time is untouched. Over here to the right of me is our shipping department. So you can see our shelves with the Starrett red box. Even if our vendor of that box, if that red comes in an offset color from what we expect and what our customers expect, we won't accept that box. So when people buy Starrett tools, They even expect the Starrett box that it comes in to be that Starrett red.
In addition to its core line of precision measuring tools, Starrett also designs and manufactures a complete line of industry-leading vision, optical, and multi-sensor metrology systems manufactured at Starrett's Kinemetric Engineering facility in California. These same systems are also utilized here in Athol throughout the plant to inspect Starrett tools and parts.
Yeah, so this is our KMR MX vision system. So it utilizes the Metrologic's MX series digital readout, a 1080p color video display, an HDMI camera, and then we have top lighting, bottom lighting, and then we have a 5-stage mag here, so allowing us to go from around 25x to around 125 magnification. So, and then we have a stage of right around 8 inches by 4 inches for travel around. So the history of a tool maker's microscope is typically we use, when you're using cutting tools, you'll want to look at the edge for wear or defects as you're using the tools. So that's kind of where this originated from, as more of an actual microscope that you'll look through the reticles. And then it's kind of evolved since then to be a digital system. So we have our digital camera, and then with the addition of a digital readout, we can actually take measurements from it. So we have another tool here, so the Starrett ruler. So this is a kind of a common application for this system. We'll see it actually a lot today on the shop floor. So we move over to different tick marks here, and we can zero it out, and then we can move and determine whether or not these are manufactured in spec. So this is an HE400 optical comparator. So it uses a mirror system and then a lens that is interchangeable, so we can have different power magnification lenses. This one here is a 10x lens, and where optical comparators really kind of shine is in a lot of lathe parts or turn parts. So the evolution from the optical comparator to a digital version here, so instead of the mirror system, we use a digital camera and an interchangeable lens as well. I can hit play here, and what it's going to do is look for this patterned image here, and all I have to do is one click on the screen, and it'll run through and take all those measurements just like that.
Starrett has a special gauge division. It's been around since 1960s, and we were designed to make the customer a gauge that is not in our catalog. So there's 5,000 or so tools in our catalog. If those won't solve your problem, we have a team of engineers and machinists that will design a solution and manufacture that solution for our customers. So we've done everything. We've measured Ruffles potato chips, we've measured Burger King hamburger patties, we've measured bombs, we've measured stuff for almost every aerospace company. If it's been manufactured, we probably measured it. The history of aerospace, right? So when you make a nozzle, when they first started making these, you have to figure out how much air is going to flow through these. Sure. So now the old way of doing it is you run water through it. So when you run water through these, you can measure how much water moves through it, and that's how my flow rate. So we've partnered up with a company that said, hey, we have a need for this. We designed it. This is what started Special Gauge. It's called an area flow gauge. And what this does is it measures how much air will flow through a specific opening inside of this.
Beyond manufacturing the company's precision tools, gauges, and metrology equipment, Starrett invests in training its new tool makers and machinists in addition to offering a broader, comprehensive precision measuring skills training program for vocational schools across the USA.
If we're hiring you on as a machinist and you don't have a lot of experience, we'd like to spend some time with you here, just understanding the controls and offsets before we actually put you in front of a live machine making production parts out in the factory. So here we are in our Starrett classroom where we're spending about 2 hours a day, 5 days a week for 4 weeks, I believe. 4 weeks this goes on. Yeah, where we're taking our newer employees and some of our veteran employees to talk about the Starrett culture, the Starrett history, how to read a blueprint, how to read our travelers, talk about quality, talk about safety here. Another program we have here at Starrett is called our PMI, Precision Measuring Instruments. And what it is, it's a tool chest of 200 tools, 20 different tools, 10 each, with a curriculum about this thick. And here's some of the tools, your basic measuring tools, whether it's a 0 to 6 inch dial, slide caliper, your combination square set, your 0 to 1 inch mic, a drop indicator, a bore gauge. And what that program is it's in partnership with Snap-on and NC3, National Coalition of Certificates, CERTs, and it's called Train the Trainer. So let's just say a tech school or a community college or a machine shop. Any and everybody could purchase that tool chest of 200 tools with the curriculum, and of course we will help and guide you and train you on how to use all these tools, and then that person would go ahead and take that and train their people, called Train the Trainer. It's very successful, and this program is crucial to the future of American manufacturers.
We hope you enjoyed Modern Machine Shop's tour of Starrett's legendary production facility in Athol, Massachusetts. This video is made possible by Starrett, a company with more than 140 years of American-made innovation in precision measurement tools, trusted by craftsmen, machinists, and engineers worldwide. We encourage you to visit Starrett.com to dive deeper into their legacy of quality solutions. And if you enjoyed this video and would be interested in featuring your company in our video tour series, just email us at shopvideo@mmsonline.com and tell us what sets your business apart.